Hello, and welcome back to Sleepy Science Stories. I'm glad you're here tonight, resting, listening, and ready to drift into the quiet rhythm of the cosmos. The lights of day have faded, and what remains is silence, the same silence that fills the space between stars. Take a slow breath in, and let it go. The air around you softens. Your body grows still, your thoughts drift outward, farther and farther, beyond your room, beyond the sky, until only darkness and starlight remain. Now, imagine our sun, burning quietly in the black sea of space. And near it, something new has appeared, a bright object, glowing with an eerie green hue, streaking across the solar system from far beyond the stars. Telescopes catch its image, a narrow jet of light reaching toward the sun. Not away, as comets usually do. Scientists call it 3I/Atlas, an interstellar visitor. But the world calls it something else, the object that might be feeding on the sun. Is it a natural phenomenon? Again, there are mysteries far bigger than our understanding. So tonight, we'll drift through the story of 3I/Atlas. Calmly, slowly, fact by fact. We'll travel with it from the darkness between stars to its strange meeting with our sun and beyond. Let your mind float through the silence of interstellar space as the facts unfold like constellations before sleep. The story begins with a question. Is something draining the sun's energy? It started as a whisper across the astronomy community, a ripple of curiosity turning into quiet astonishment. Telescopes began to detect a faint disturbance in the luminous rhythm of our sun, a slight irregularity in its corona that no one could quite explain. It wasn't dangerous, but it was odd, a delicate thread of light seemed to be stretching toward the sun instead of away from it. In an age when space observatories track everything from solar winds to distant quasars, nothing escapes our attention for long. Yet this was different. Could something truly be drawing energy from the sun? The thought alone sounded absurd, even poetic. Stars give, they don't lose. But every mystery begins shooting into the sun, not away. In early 2025, a chain of observatories, from Hawaii to Chile, recorded a phenomenon unlike any comet or asteroid behavior ever seen. Against the blinding brightness of the solar disk, a thin, concentrated jet of material appeared to move inward. Normally, solar radiation and wind push matter outward, carving long comet tails that stream away into. Scientists rechecked their instruments, recalibrated sensors, and waited for confirmation from independent observatories. Within hours, the same strange jet appeared again. It was real. 3I/Atlas. The I was crucial. It meant interstellar, a visitor from another star. The first few orbital measurements showed that it wasn't looping around the sun, but slicing through our system on a one-time path. A traveler, not a resident. Astronomers around the world focused their instruments toward it, tracing its speed, its rotation, its brightness curve. Somewhere in that speck of interstellar, meaning it came from outside our solar system. To call something interstellar is to admit it doesn't belong here. Most comets are local, fragments of ancient ice left over from fingerprints of an alien chemistry. The I in 3I/Atlas is not just a classification. It's a story condensed into one letter, a symbol of distance, history, and mystery. It tells us, discovered in 2017, a cigar-shaped mystery that passed silently through the inner solar system, leaving behind more questions than answers. The second, 2I/Borisov, appeared in 2019, a true comet. Invisible forces. Borisov looked natural, yet its composition hinted at materials rare in our own comets. 3I/Atlas, however, added a new twist, a jet toward the sun. 3 visitors, 3 riddles, and perhaps 3 chapters in a larger cosmic story we are only beginning to read. Astronomers first noticed its unusual trajectory in early 2025. It started as a faint speck moving against the background of fixed stars. Automated sky surveys, scanning millions of points of light each night, flagged it for its abnormal speed and curved trajectory. The motion didn't fit the pattern of asteroids or regular comets. When orbital predictions were run, the line didn't close into an ellipse. It opened outward into a hyperbola. The message was clear. This object was passing through, not staying. For days, teams across the world confirmed the data. It wasn't bound to the sun, whatever it was. It had come from deep interstellar space, bearing both mystery and momentum. Something different. It means escape. It means the traveler came from beyond and will never return. The sun's gravity slows it slightly, bends its path, and then releases it again into the galaxy. 3I/Atlas's trajectory cuts through the solar system like a skipping stone through water, a brief touch, then gone forever. Its speed, nearly 90 kilometers per second, ensures it will not be caught. Spotted it. The Asteroid Terrestrial Impact Last Alert System. Atlas is not a mythological name this time, but an acronym, a network of telescopes in Hawaii and Chile designed to detect incoming. A faint, greenish blur moving too fast and from the wrong direction. Atlas logged it, flagged it, and sent an automatic alert to the Minor Planet Center. Hours later, astronomers realized they had just witnessed something extraordinary, not a threat, but a messenger. The system built to guard our planet had instead opened a doorway to the stars. The 3I label means the third interstellar object ever confirmed. The numbering system is simple yet monumental. The 3 marks it as the third of its kind. In the grand scale of cosmic history, 3 may seem small, but for human understanding, it's immense. Out of countless comets and asteroids, only 3 have been confirmed to come from other stars. Each one expands the map of what is possible. The label 3I is like a bookmark placed in the story of the universe. It tells future generations where we stood when we realized the cosmos could visit us back. As it approached the sun, its brightness flickered in strange patterns. Astronomers measure brightness curves, gentle graphs of light that rise and fall as comets spin, melt, and release gas. But 3I/Atlas didn't behave like that. Its brightness fluctuated rapidly, almost rhythmically, as if pulsing with some hidden cycle. The variations were too regular to be random and too complex to be explained by simple rotation. Some thought it was. Observers saw not just data, but personality. It was as if the object itself was blinking, aware of the gaze fixed upon it. Then came the shock. A jet appeared pointing directly toward the sun. When the first images of the jet appeared, the scientific community paused. The plume was thin, luminous, and unmistakable. Every known comet emits its tail away from the sun, driven by solar. Wasn't an illusion. The plasma density and angle were consistent with an inward flow. For the first time, astronomers saw an object apparently pushing matter toward, not away from, a star. The footage spread instantly, not just through data networks, but through imagination. No comet had ever shown that before. Across all centuries of observation, from Galileo's first telescope to NASA's Parker probe, no comet, asteroid, or interstellar body had ever displayed such behavior. Comet tails are textbook examples of solar influence. Radiation pressure and charged particles push dust and gas outward. The sight of one reversing the rule was like watching gravity run backward. Scientists searched archives, compared old data, even simulated the plasma dynamics. Nothing matched. The phrase unprecedented appeared again and again in research notes. For once, the sky had done something we didn't expect, and that, in itself, was a gift. Some scientists called it the energy siphon. The nickname spread faster than any formal publication. The energy siphon. It sounded dramatic, even mythic, but there was something fitting about it. The jet looked as if it were drinking sunlight, drawing brightness into its narrow stream. Of course, no actual energy theft was happening in the thermodynamic sense. Yet the metaphor captured the feeling of it, the eerie sight of a comet appearing to feed from a star. The name stuck, whispered across forums and news outlets. For a moment, science and poetry became one, united in wonder. Others insisted it's just a rare solar reaction. Skeptics quickly offered explanations grounded in physics. Maybe the sun's magnetic field had interacted with the comet's ionized gases, twisting them inward. Perhaps solar wind. Storytellers reshaped it into myth. For a brief moment, across languages and borders, millions of people looked at the same image. Not a celebrity, not a disaster, but a distant phenomenon in space. And they all felt the same quiet emotion. Awe. In a world of noise, one strange beam of light had managed to make us look up again. Could it be alive? A machine? A miracle of physics? The questions began to multiply, as they always do when reality surpasses expectation. Some speculated about alien technology, others about unknown plasma dynamics. Could a comet behave intentionally? Could matter organize itself in ways that mimic intelligence? The boundary between science and imagination blurred. Every possibility, no matter how wild, became a doorway for curiosity. Humanity's oldest instinct resurfaced, the need to assign meaning to the unknown. Whether 3I/Atlas was natural or engineered didn't matter yet. What mattered was that, for the first time in a long while, the universe had surprised us again. The mystery became a mirror of our curiosity. In studying 3I/Atlas, we weren't just observing an object, we were observing ourselves. Our need to explain, to classify, to believe. The excitement and fear it stirred revealed how deeply we crave contact with the unknown. The object-silent approach became a mirror reflecting human emotion on a cosmic scale, fascination, humility, even a touch of longing. We projected stories onto it, just as ancient people once did with stars. Perhaps that's our greatest constant. Dependable, life-giving. But now, it seemed to play a different role, a backdrop for mystery. Against its steady blaze, a single strange jet asked a silent question. How much do we really know about the forces that govern our cosmic neighborhood? Can the universe still surprise even the most advanced instruments we've built? The sun burned on, indifferent yet illuminating, and in its light, we glimpsed the limits of our understanding. What if something is learning how to feed from stars? It's a daring question, one that borders on science fiction, yet feels hauntingly possible. If, from suns to continue their journey. Or maybe this is how civilizations migrate, not through messages or ships, but through the physics of light itself. The idea unsettles and enchants in equal measure. Whatever the truth, 3I/Atlas makes us look at stars differently, not just as lights in the sky, but as power sources in a galactic web of existence. And so, the journey of 3I/Atlas begins. But in motion, as it glides through the solar wind, we follow, curious, humbled, and wide awake beneath the endless night. Before reaching our sun, 3I/Atlas traveled for millions of years. Every orbit of the Milky Way brought it past different constellations, unseen by any world capable of noticing. In that immense span of time, it passed close to other stars. Through dust clouds, through magnetic tides that bent its path slightly, but never stopped it. Its journey was not planned. It was the result of ancient chaos, gravity's long memory at work. And so it kept going, silent, cold, and indifferent to the ages that passed around it. By the time it reached us, civilizations had risen and fallen, species had come and gone. Yet the traveler remained, still on its path, still bearing the story of another sun. its path cut through interstellar space, a void between stars. Between stars lies a gulf so vast that even light, traveling at 300,000 kilometers per second, takes years to cross it. This is interstellar space, a region not of emptiness, but of almost nothingness. A few atoms per cubic meter, wisps of hydrogen, and the occasional lonely dust grain. 3I/Atlas wandered through this realm like a ghost ship sailing a sea of silence. Here, temperature is near absolute zero, and the only sound is the cosmic background radiation, the ancient echo of the universe itself. The object's surface, frozen solid, preserved whatever history it carried. No erosion, no atmosphere, no noise, only. When scientists examined the reflected spectra from 3I/Atlas, they found signatures of materials that had crystallized billions of years ago, before our sun was born. The dust coating its exterior is like time made visible, grains forged in ancient supernovae, scattered across the galaxy, later merging into comets and planetesimals around young stars. Some of that stardust found its way into 3I/Atlas. Each particle is a memory of cosmic fire, containing isotopes no longer common in our neighborhood of space. In studying it, we are literally looking at matter that predates Earth, predates even the idea of life. Its dust is not merely old, it is ancestral. Some models trace its origin to a red dwarf system beyond Lyra. Computational simulations have tried to retrace the flinging nearby debris outward at enormous speeds. Imagine a quiet, dim solar system, orbiting a cool crimson sun, and from it, a fragment cast into the dark, destined never to return. Expelled during such an event, that would explain its speed and peculiar composition, mixed metals and ices fused under sudden, violent pressure. If so, its journey began not in quiet orbit, but in cataclysm, a moment of stellar death that turned a local rock into a galactic wanderer. What to us looks peaceful now may have been born from cosmic violence. Even beauty has its explosions. 3I/Atlas is a messenger from another sunrise. To call it a messenger is poetic, but not entirely inaccurate. Every interstellar object carries with it chemical messages, ratios of hydrogen, carbon, nitrogen, and oxygen that tell scientists about the star system it came from. 3I/Atlas is a sample return mission not launched by humans, but by nature itself. Its presence near our sun is an accidental delivery from another dawn, a sunrise that once glowed in a different corner of the galaxy. Somewhere, eons ago, its parent star shone on worlds we'll never know, and this object was part of that ancient neighborhood. Now, as sunlight touches it for the first time in millions of years, it glows once more, a spark reignited by a new star. Its ice contains chemical fingerprints of a foreign world. Spectroscopic analysis of 3I/Atlas's coma revealed something unusual. The ratio of carbon dioxide to water vapor was unlike any comet we've seen in our own system. There were traces of complex hydrocarbons, perhaps even simple organic precursors, but in proportions that don't match local chemistry. This means its ices were formed under different stellar radiation, different cosmic dust, perhaps different levels of ultraviolet flux. In essence, it is a frozen record of another planetary nursery. Each molecule inside it holds clues about how other solar systems form, how their comets grow, how their chemistry differs from ours. It's as if we've been handed a sealed vial from an alien ocean, carried across space by time itself. It may carry molecules compounds formed under extreme conditions, or even isotopic variants unique to other stellar environments. Scientists compared them to known substances like tholins, polycyclic aromatics, and nitriles, but none fit perfectly. If confirmed, this would mean 3I/Atlas harbors chemistry that doesn't exist, or no longer exists, in our part of the galaxy. each unidentified peak in its spectrum is a potential discovery waiting for future missions. It reminds us that the universe is still inventing, still mixing elements into recipes we haven't tasted yet. Every atom on it once belonged to another solar wind. Atoms move endlessly, cycling between stars, planets, and comets. The iron in your blood once belonged to a star. The carbon in 3I/Atlas once drifted through another. It wandered through cosmic dust clouds for eons. Between stars lie vast molecular clouds, cold, slow-moving nebulae filled with gas and microscopic particles. As 3I/Atlas drifted through them, its surface collected thin coatings of interstellar dust. Cosmic rays scarred it. Stray ions embedded themselves like ancient graffiti. Over time, these layers built up a history, a geological record of the galaxy's invisible regions. Every impact, every atom that settled on its crust, became part of its identity. The object is not a blank rock, but a palimpsest, a tablet on which and uneven, like a weathered sculpture left out in the cosmic storm. Over millennia, these scars accumulated, giving the object texture, complexity, and a strange kind of beauty. And those scars are light. That's why some comets appear green as they approach the sun. In 3I/Atlas, this effect is amplified by its composition and speed, giving it a distinctive jade hue. The glow is not alive. Around it, spectrometers detected faint metallic lines, signatures of iron and nickel vapor mixed with cyanide gas. Together they create a halo of light, shimmering faintly in ultraviolet. The metals likely come from microscopic grains buried in its ice, released as the sun's heat reaches deeper layers. The mixture forms an iridescent aura, both chemical and symbolic. Together, whispering the story of stars that lived and died long before our own. Scientists say its composition is unlike any known solar system object. Comparing spectra to our catalog of over 4,000 comets, 3I/Atlas doesn't quite match any. Its balance of volatiles, metals, and organics sits outside familiar ranges. Some ratios resemble outer Kuiper belt objects, others echo exoplanetary debris disks. The more we study it, the more alien it becomes. This is not just another comet visiting from afar. It's a sample of the galaxy's diversity, a reminder that our solar system's chemistry is not universal. Somewhere out there, other suns forge different recipes, and once in a while, one of their creations drifts into our sky, asking us to compare notes. The void gave it silence and memory. For millions of years, 3I/Atlas drifted without collision or sound. Silence in space is not emptiness, it is preservation. Without atmosphere or erosion, its surface kept every detail intact. The cracks from distant impacts, the frost lines from old outgassing, the composition of alien dust. In that stillness, memory accumulated. The object became a vessel of time, carrying evidence of regions we've never reached. When we observe it, we are reading the diary of the void, written slowly, patiently, by physics alone. Each turn around a star changes a traveler's face. Every time a comet approaches a star, it awakens. Ice turns to vapor, gas escapes through fissures, material reshapes the surface. 3I/Atlas, too, has had its share of close. Over time, these encounters give a traveler personality. No two comets look the same after a journey through light. To watch 3I/Atlas near our sun is to see its face change once again, glowing, shedding, reborn. 3I/Atlas has seen more than we ever will. If consciousness were measured by experience, this object would be a sage. It has witnessed the births and deaths of stars, the slow drift of nebulae, the collisions of planets in distant systems. While life on Earth took shape in oceans, 3I/Atlas was already crossing the Milky Way, gathering traces of the cosmos. between galaxies, and found us. Though not literally leaving the Milky Way, 3I/Atlas passed through the vast outer arms, regions so empty they feel like intergalactic bridges. The darkness there is. It found ours. By random or by design, its path intersected with the only species capable of wondering why. It arrived by chance or design. Chance is the simplest answer. The universe is full of two things met: a traveler from another sun, and the eyes of a species awake enough to wonder. We noticed, and by noticing, gave meaning to its voyage. It has no need for applause. Line between unknown and known. 3I/Atlas did. And for a brief, beautiful moment, it reminded us that even across millions of years and billions of kilometers, connection is possible. All it takes is a mountain drifting through the dark. Telescopic brightness and thermal readings suggest a body around 10 kilometers wide, large enough to survive close passes near the sun without completely vaporizing. That size makes it both fragile and formidable, small enough to glow, big enough to endure. If you could stand on its surface, gravity would be almost zero. A gentle step could send you floating into the black. Yet within that small world lies an archive of chemistry from a different star, a frozen core that has traveled longer than the entire history of human civilization. Sunlight differently as it spins, causing the gentle flicker seen through telescopes, a slow cosmic heartbeat. To the imagination, it looks like a splinter of a planet, a shard from a forgotten 3I/Atlas. The echoes came back stronger than models predicted. That meant one thing: density. Its core may contain heavy elements, metals compressed under ancient pressure, rather than pure ice. Perhaps a remnant of a larger body's interior, torn free in a stellar event and frozen mid-eruption. Such density changes how sunlight warms it, how jets erupt, how long it can survive near stars. A compact core acts like a spine, holding together the brittle layers of ice above. Inside that unseen heart could rest materials forged in another sun's furnace, dense, old, and waiting. Its albedo is low, meaning it absorbs more light than it reflects. Unlike the icy glint of many comets, 3I/Atlas is dark. Its surface reflects barely a few % of the sunlight that strikes it. As black as charcoal, as heat-hungry as asphalt. This low albedo suggests a coating of carbon-rich dust and radiation-burn organics. Across millions of years, cosmic rays darken ice into a crust that traps warmth. When the traveler nears a star, that trapped heat releases buried gases in sudden bursts, the spark of its mysterious jet. Its darkness is not absence, it's the record of countless years under interstellar radiation. It's the color of endurance. The surface is covered in volatile ices, CO2, methane, and ammonia. Spectral analysis paints a chemical portrait. These layers awaken one by one, faint exhalations that form the object's delicate coma. Such ices are clues to its birthplace, a cold, outer region of another star system where temperatures plunged. A veil of fine dust grains lifted by escaping gas. From Earth's perspective, it looks like a soft halo, almost transparent, scattering sunlight into a faint green shimmer. Each grain is smaller than smoke, charged by solar radiation, dancing in slow spirals through magnetic currents. This veil is what makes comets beautiful, but for 3I/Atlas it also hides its true form. Within that haze, cameras struggle to see the body clearly, as if the traveler guards its own identity behind a luminous mist. Spectroscopy revealed carbon chains never seen in Borisov or Oumuamua. These chains are born when ultraviolet light breaks apart simpler gases and reassembles them into rich organic networks. The presence of such compounds implies an resemble though complex organic molecules. Tholins form when sunlight and cosmic rays act on methane and nitrogen, creating reddish-brown residues. They coat moons like Titan, tint Pluto's plains. Wrapped in deep rust-red material, a palette painted by chemistry, not intention. These tholins are inert here, but elsewhere they could be seeds, molecules that, when warmed and mixed with liquid water, form amino acids. The traveler may be carrying the ingredients of potential life, unknowing and endless. The jet activity seems to come from a single narrow vent. Images from multiple observatories show one focused source of outflow, not a diffuse eruption. That means there's a vent, a crack or hollow funnel, guiding gas in a single direction. As the sun heats the region beneath, pressure builds until it bursts outward through that opening. The precision of the jet astonished researchers. It behaves like a nozzle rather than a chaotic plume. Such singular vents can. Pointing back toward the sun, imagine a frozen mountain with one glowing wound, venting vapor not outward but inward, straight at the star. That narrow jet becomes a luminous spear. Fractures align, heat follows weakness, physics paints symmetry. Still, the image is unforgettable, a dark shard exhaling a bright breath toward the sun, as if reaching back to the source of its awakening. The outflow creates a reaction force, subtle but real. Every action has its echo. As gas rushes one way, momentum pushes the body the other, though tiny compared to gravity. The cumulative thrust from the jet nudges 3I/Atlas's path by measurable degrees. In mission engineering, this is the principle of propulsion. In comets, it's called non-gravitational acceleration. For 3I/Atlas, the force may equal the push of a feather on a mountain, yet across millions of kilometers, it matters. Its trajectory shifts, its spin changes, and suddenly the visitor moves with a passive rock obeying orbits. Its jets give it agency, however mechanical, a means to drift differently from what equations predict. For spacecraft, we use thrusters to steer, nature uses sublimation. The idea that this interstellar traveler could gently steer itself through nothing but physics adds poetry to the science. It blurs the line between object and vessel. Every puff of gas is a whisper of motion, every spin a choice carved by sunlight alone. The jet composition is rich in CO2, a clue to deep ice melting. Carbon dioxide ice requires more heat to vaporize than water. Its presence in the jet suggests the vent reaches deep below the surface, tapping layers untouched for eons. Perhaps the sun's warmth penetrated cracks left by ancient impacts, awakening dormant. Spectacle. It's a revelation of what lies within. The chemistry of alien dawns now exhaling into our solar wind. Some models show a rotational period of 9 hours. By tracking variations in brightness, astronomers estimate 3I/Atlas spins roughly once every 9 hours. That's a gentle rotation, enough to expose different faces to sunlight and create rhythmic patterns of outgassing. Every 9 hours, a sunrise and sunset pass across its rugged terrain. The repeating jet flares like a heartbeat, 9-hour cycles echoing through space. It turns steadily, unhurried, like a sleeper rolling through dreams under distant suns. Others suggest it tumbles chaotically like Oumuamua. Not all agree on the calm rotation. Some data fits better with a complex. Never repeats the same orientation twice. If 3I/Atlas shares that trait, then its jet might flicker in unpredictable rhythms, explaining the strange light variations. To tumble is to surrender to. Iron-nickel alloys can hold residual magnetism from their formation, fossilized magnetic lines imprinted when the metal cooled around a young star. If these readings hold, then 3I/Atlas carries within it the magnetic memory of another solar system's birth. A compass frozen from an alien dawn, still pointing somewhere far beyond our reach. It may carry its own electromagnetic field. As charged gases flow from its jet, they interact with solar plasma, generating faint magnetic loops that wrap around the nucleus. This induced field is weak, millions of times gentler than Earth's. Yet it gives 3I/Atlas a kind of aura. Charged particles follow these invisible paths, creating glowing filaments captured in ultraviolet photographs. In a sense, the comet writes lines of force, as if ionized by solar plasma. Spectrometers on board solar observatories detected strong ultraviolet emission lines near the jet. These come from ionized carbon and oxygen atoms, signs that solar wind particles are energizing the outflow. When those charged atoms recombine, they release light invisible to human eyes but brilliant in UV sensors. The process is violent and elegant at once. Sunlight tearing molecules apart, then letting them glow as they heal. To instruments, it appears as a violet-white beam stabbing toward the sun, a bridge of energy linking fire and ice. The jet extends like a narrow ribbon all the way toward the solar corona, fading only where glare overwhelms sensors. Photographers describe it as a thread of light, delicate yet immense. A structure both physical and spectral. It's not solid, not even stable, just energy sculpted by magnetism. But to those who see the images, it feels like intention, a bridge from wanderer to star. From question to answer. A silent connection between a star and a wanderer. In the end, that's what the phenomenon becomes, a momentary link across cosmic scales. A traveler from another sun. Worlds. For a brief time, 3I/Atlas is not just an object, but a participant in the sun's great story. And when it moves on, it will carry with it the memory of that connection, a line of light drawn between two suns, now fading into the dark. Every comet points its tail away from the sun, except this one. For as long as humans have drawn maps of the heavens, comet tails have behaved the same way. The physics is simple. Sunlight and solar wind push dust and gas outward, so every tail points away from its star. It's a universal rule, as old as astronomy itself. Yet when images of 3I/Atlas appeared, that rule broke. Its beams stretched inward, not outward, as though the traveler had turned to face the very furnace that should have repelled it. To watch a law of nature bend, even slightly, is to feel both humility and thrill. The cosmos, it seems, still keeps secrets under its bright skin. The sunward jet defied centuries of astronomy, from Galileo's sketches to Hubble's photographs. Comet behavior has been textbook predictable, but 3I/Atlas refused to fit. The jet's orientation contradicted not just observation, but fundamental solar wind mechanics. The discovery sent quiet ripples through scientific circles. Not panic, just fascination. The kind of excitement that wakes researchers at 3 a.m. If something this simple can invert, what else? Maybe magnetic tension lines twisted the plasma backward. Maybe the vent geometry caught sunlight just right. Or maybe the universe simply allowed an exception, a reminder that even wind has eddies. Cold reaching for fire. Scientists called it a reverse outgassing event. Labels bring order to mystery. Reverse outgassing became the term of the week, an attempt to describe the indescribable. Normally, as comets warm, volatile ices sublimate and blow away from the sun. In 3I/Atlas, perhaps a deep vent opened on its far side, so the jet emerged from the shaded hemisphere, appearing inverted. Simple, plausible, and yet the geometry didn't fully fit. The name stayed anyway, a linguistic placeholder between ignorance and understanding. Sometimes, naming a mystery is the If 3I/Atlas wandered into a region of reversed polarity, its ionized gases could have been drawn sunward temporarily. That's one hypothesis, elegant, testable, yet incomplete, because the jet lasted too long, too stable, for a passing fluctuation. Every simulation ends with perhaps. The data leaves space for doubt, and in that space wonder grows, the recognition that physics is not finished. Writing its book, the beam looked like a thin thread of ionized gas. Through ultraviolet filters, the jet appeared almost solid, a glowing filament tens of thousands of kilometers long, yet narrower than a city on Earth. It was composed of ions, atoms stripped of electrons, glowing as they recombined. The beam quivered slightly, as if alive in the magnetic wind. Observers described it as a thread of glass, fragile, trembling, but persistent. Its texture was neither dust nor vapor, but something in between, matter balanced on the edge of light itself. It pulsed in brightness. Geometry, linking shells, storms, galaxies, and now this. A comet breathing light in a helix toward the sun. Patterns repeat across scales, as if the universe practices handwriting. And solar wind can braid the beam into a luminous corkscrew. Computer models recreate the shape easily, but not the inward direction. The physics of rotation can draw circles, yet it shouldn't. Reverse the arrow of the tail. So the question remains, what turned the spiral sunward? In that unsolved twist lies the beauty of the phenomenon, order meeting enigma. Or was it energy transfer? Lines of force may have connected briefly, transferring charged particles along invisible conduits. Such magnetic reconnection happens on the sun all the time, powering solar flares. To see it mirrored on a comet would be astonishing, a small echo of stellar behavior on an icy fragment from another star. For a few moments, the boundaries between object and star might have a local disturbance, like a pebble nudging a wave. The energy scales don't quite match, but curiosity doesn't care. The flare became part of the story, a punctuation mark in light, as if the sun had answered the visitor's call. Coincidence, or a response? Science says coincidence. Imagination says conversation. To skeptics, the flare was random. To dreamers, it was reply, a pulse of fire, acknowledging the approaching beam. Between those views lies the space where wonder lives. The universe may not speak in language, but it does in timing, in symmetry, in echoes. Whether the flare, right next to mystery, the humility of knowing it might change everything we thought solid. Data from SOHO and Parker Solar Probe recorded a density anomaly when scientists cross-checked solar wind. The difference was marginal, fractions of a percent, but enough to be real. Something in that area was momentarily altering the flow of solar particles. A pocket of slowed plasma. Solar particles near the object slowed down slightly. Further modeling suggested that the charged particles streaming past 3I/Atlas lost velocity, as if encountering resistance. Perhaps it's magnetic. Real enough to stir curiosity. In that hesitation of particles, one could almost imagine the sun pausing to take a breath, sensing the stranger in its light. That sparked the headline. Draining the sun? The media loves poetry, and science sometimes gives it willingly. Within hours, articles spread with bold titles. Is something feeding on the sun? The phrase draining energy was. Physics remains calm amid headlines. The sun's energy output is 3.8 times 10 superscript 2 watts, enough to power billions of Earths. Nothing a 10-kilometer rock could do would make the slightest dent. The jet wasn't feeding, merely reflecting and interacting. Yet that reassurance didn't dull the wonder. Knowing the laws doesn't erase the beauty of their exceptions. Sometimes, the imagination must run ahead so that science remembers what to chase. But phenomena often mock our understanding first. History is full of discoveries that began as impossibilities. X-rays, radio waves. The beam that seemed to pull from the sun could reveal new plasma physics, new behaviors of interstellar ice, or simply new humility. Every mystery begins as mockery of certainty, and every answer. The angles shifted, and ordinary sunlight resumed. Yet in the memory of our instruments, and in our collective imagination, the picture remains. A moment when the sun seemed generous. Ices, they turned to vapor and burst through cracks, forming jets that twist and flare. That's the language of comets, ordinary and elegant. Nothing supernatural, just physics under sunlight. For 3I/Atlas, this model fit, almost. The vent geometry, the spin, the composition, each piece could, in theory, make a jet aim inward. Astronomers favored this because nature prefers simplicity. It asks no intention, no design, only coincidence and chemistry. Yet even the calmest scientists admitted the spectacle felt uncanny, as if the laws they trusted had smiled and winked. Hidden in chaos. The jet's edges looked too clean, its cone too sharp. They noted its steady width over thousands of kilometers, behavior unusual for a random vent. To them, it resembled a collimated exhaust plume, the kind engineers designed for precision thrust. Was it coincidence or craftsmanship? Data alone couldn't tell. The human brain hungers for pattern, and pattern breeds hypothesis. Science demands restraint. Imagination asks only curiosity. Between those two, speculation finds a home, glowing faintly like the jet itself. Part nature, part design. Avi Loeb, known for Oumuamua theories, commented again. When the name Avi Loeb appeared in headlines, few were surprised. Years earlier he had proposed that Oumuamua, the first interstellar object, might be artificial, a light sail sent by another civilization. Now, with 3I/Atlas, reporters sought him again. He spoke carefully, not declaring belief, but inviting questions. If nature can mimic technology, how do we tell but by measuring it until it becomes either truth or poetry. Could 3I/Atlas be a probe using the sun for maneuver boost? Among the bold ideas circulating online was one drawn from astronautics. Perhaps this visitor was a craft performing a solar-assisted acceleration, a maneuver using the sun's gravity and heat as fuel. If a probe were capable of controlled outgassing, releasing material at propulsion, no evidence proved such intention, yet the thought thrilled engineers and dreamers alike. To imagine intelligence using the sun not as destination but as launch pad, it felt almost poetic. A union of curiosity across species unseen. The idea comes from the Oberth effect. The Oberth effect is a real principle. Burn fuel deepest in a gravity well, and the energy multiplies. Attempted. In numbers, it would mean acceleration of tens of kilometers per second, a perfect exit velocity for a galactic messenger. Physically plausible, yes. Intentionally designed, doubtful. A craft falling toward a star, its path bending like silk around flame, releasing a burst of energy at the exact instant of closest approach. Gravity amplifies the burn, and the object flings itself outward faster than any rocket could manage. That's the essence of an Oberth maneuver. If nature created such an effect accidentally through venting, it would be a miracle of coincidence. If engineered, it would be a masterpiece of navigation. Either way, the principle reminds us that gravity is not merely a force, it's a partnership between motion and opportunity. The sun, temperatures hotter than molten metal and timing accurate to milliseconds. The engineering borders on myth. If 3I/Atlas were truly artificial, whoever made it would have mastered both physics and ignorance still is. Sometimes imagining advanced minds helps us glimpse our own potential, even if the messenger is only ice and dust. Others suggest it could be a derelict probe from a dead civilization. Among the quieter speculations lies a melancholy one. What if 3I/Atlas is not a visitor on purpose, but a relic, an abandoned probe, drifting long after its makers vanished? Unnoticed. A derelict craft crossing the void is not impossible. It's statistically poetic. Whether organic or engineered, it would still be a monument to time, proof that nothing, once created, truly stops moving. Perhaps activated when detecting solar radiation. One curious pattern sparked imagination. The jet seemed to brighten precisely as solar flux increased. Could an old mechanism, buried in ice, becomes a heartbeat? Or maybe just a frozen comet that spins the wrong way? Not every mystery needs grandeur. Some comets simply rotate retrograde, spinning opposite to their orbit, producing jets that, from certain angles, appear inverted. Combine that with the sun's magnetic irregularities, and you might get a tail that seems to point inward. No aliens, no probes, just geometry. And yet, even that explanation carries wonder. Because even a random spin, in the right light, can sculpt beauty that feels deliberate. Nature doesn't need intention to imitate art. Our minds fill mystery. When the unknown crosses our heavens, we write its story to bridge distance. 3i/Atlas has already joined that lineage, becoming both data and legend. It reminds us that myth is not falsehood. It's curiosity wearing poetry's clothes. Every generation names its comets according to the dreams it needs most. This one, perhaps, names them for connection. Each theory reveals more about us than the object. Scientists propose equations. Believers propose purpose. Skeptics propose chance. All three describe not the comet, but the boundaries of human perception. Our theories are portraits of ourselves, our logic, our fears, our hope that the universe notices us back. 3i/Atlas is indifferent to interpretation. It simply moves. Yet by studying it, we expose our own architecture of thought. Imagination fills the gap. The universe rarely replies to questions directly. It answers through beauty and indifference combined. So we dream, not out of arrogance, but necessity. Dreams are how curiosity breathes when certainty runs out. 3i/Atlas reminds us that unanswerable questions can still be worth asking. Perhaps that's their only purpose, to keep the dialogue alive between knowing and not knowing. And still we keep asking. Every photograph, every spectral scan, every model is another form of the same question. What are you? We build better telescopes, send probes, simulate orbits, all to decode a message that may not exist. Yet the pursuit itself defines us. To keep asking, even into silence, is to stay awake within the universe. That persistence, more than any answer, is humanity's signature among the stars. 3i/Atlas remains silent. No radio signal, no modulation beyond natural patterns. Just light reflected, gases released, motion sustained. Silence, however, is not emptiness. It's information in its own way. A quiet object teaches patience. A mute sky trains observation. In that silence we hear our own thoughts more clearly. It neither performs nor protests, it simply exists. That neutrality is maddening and liberating. It means the mystery is ours to sculpt. 3i/Atlas becomes whatever lens we choose. Machine, comet, omen, poem. Its refusal to explain is a kind of generosity. It lets every viewer see themselves reflected in its light. Its signal is light, its language, motion. All that reaches us are photons and trajectories. Yet in them lies eloquence. Every change in brightness, every shift in orbit, speaks through physics more gracefully than words. Light and motion are the universal dialect, understood by stars, planets, and curious minds. In observing, we learn to translate silence into meaning, to read grammar written in gravity and radiation. 3i/Atlas talks constantly. We're just learning how to listen. Every frame of data is a verse of a cosmic poem. Astronomers capture frames, lines of numbers, spectra plotted on screens. But to those who linger on them, each pixel becomes a syllable, each graph a rhythm. Together, they form verses of a poem authored by the universe itself, an epic written in light years and electrons. 3I/Atlas is one stanza in that. The data will evolve, but the conversation will never end. Science will measure, philosophy will interpret, and humanity will dream. Some will see only frozen gas, others a whisper from beyond. That dialogue, the one between reason and wonder, is what keeps the species alive and the stars relevant. 3I/Atlas will fade into the dark, but its echo remains in us, a reminder that curiosity is our. 2017, telescopes in Hawaii detected an object moving too fast at too strange an angle to belong to the family of planets and comets we know. It was named Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. The name alone felt prophetic, like the beginning of a new era in astronomy. For centuries, we had watched comets come and go, always from within our sun's realm. But a crossroads where distant worlds occasionally send pieces of themselves drifting by. Discovered in 2017, the first interstellar object. Oumuamua was identified by the Pan-STARRS telescope on October 19, 2017. Within days, its trajectory told the tale, a hyperbolic orbit, steep and fast, slicing through the inner solar system before heading back into the dark. It wasn't orbiting the sun, it was simply passing through. For the first time, astronomers could confirm that a solid object had entered our system from the interstellar void. It was the first of its kind. Separate, suddenly felt connected, like neighboring oceans sharing a current. Oumuamua had no coma, no tail. Most comets reveal themselves through vapor, bright tails of gas and dust streaming away. Under solar heat, Oumuamua had none. It remained stubbornly bare, reflecting sunlight, but shedding nothing visible. No coma, no tail, just a silent shape hurtling through the void. Stars without releasing a trace. It was as if the cosmos had sent us a whisper written on stone, rather than a shout made of fire. It accelerated slightly without explanation. When Oumuamua left the inner solar system, its speed increased, ever so slightly, yet measurably. Gravity alone couldn't account for it. Something gave it an extra push. Some suggested outgassing too faint to detect. Symbol of scientific humility. Even with all our instruments, the universe can still move in ways we can't predict. It was as though the visitor, silent and uncooperative, had winked at us before, vanishing back into the dark. Then came 2I/Borisov in 2019, a true interstellar comet. 2 years later, before the wonder of Oumuamua had faded, another messenger appeared. Amateur astronomer. In behavior, but alien in composition. Its gas is richer in carbon monoxide than any local comet. If Oumuamua was enigmatic in silence, Borisov was eloquent in familiarity, speaking a language we've known since childhood illustrations. Yet within that familiarity lay difference. Its chemical ratios suggested it formed in a region far colder and richer in volatiles than our own. The sight of it comforted astronomers. Something foreign yet understandable, like meeting a stranger who smiles in a language you know. Borisov's normalcy was its wonder. It reminded us that even across light years, physics writes similar stories on different pages. 3I/Atlas seems a hybrid of the two. Then came 3I/Atlas, and with it, the sense of connection. It shares traits with both predecessors, Borisov's bright emissions, Oumuamua's peculiar trajectory. It glows like a comet, yet behaves like a mystery. It is as if the universe combined silence and spectacle into a single phenomenon, teaching through contrast. 3 objects, 3 archetypes, the invisible, the familiar, and the paradoxical. Together, they form a trilogy of discovery, showing us that interstellar travelers can be as varied as the stars that send them. Visible jet like Borisov, but odd trajectory like Oumuamua. 3I/Atlas carries Borisov's luminous beauty, the visible jet, the rich chemistry. Precision, its path a near-perfect hyperbola. The resemblance feels deliberate, though we know it's not. Each motion, each anomaly, ties the three objects into a sequence, as if the galaxy were. That the interstellar medium can deliver ordinary miracles too. And now 3I/Atlas teaches us complexity, that the line between natural and strange is thin and flickering. Every object expands the vocabulary of what normal means in the cosmos. Each one carries a question to replace the answers we thought we had. Like ancient travelers bringing news from far kingdoms, they arrive bearing information, then depart before we can ask all we wish to know. The universe sending chapters of a cosmic book. If we could read the cosmos like literature, each interstellar visitor would be a wonder. The universe doesn't speak in language, but in patterns, timing, and recurrence. 3 visitors within a single decade, after billions of years of silence. That alone feels like punctuation. Visible cause, an invitation to reconsider inertia, drag, and radiation pressure. It made scientists revisit equations they thought complete. Some joked that Newton had stirred in his grave that week. Others quietly rewrote their models of interstellar drift. To move without mass is impossible, and yet it happened before our eyes. Perhaps it wasn't weightless. It was just carrying a physics we don't yet speak fluently. Second, ice from beyond. Borisov was the opposite. Weighty, brilliant, bursting with gas and dust. Its tail gleamed with exotic ices, including ratios of carbon monoxide that dwarfed our own comets. In that excess lay difference. It had formed farther from its home star, where even carbon monoxide could freeze solid. Through Borisov, we glimpsed alien weather, storms that, where the first was silent and the second predictable, the third performed a miracle of geometry, a jet that pointed homeward, as if to salute the star it approached. It wasn't just science, it was. And here they find it. Each object stranger than the last, each appearing a little closer in time, as though a pattern of communication were unfolding. We can't prove connection, but the sequence feels deliberate in the same way waves feel rhythmic, because our senses crave harmony even in randomness. Maybe chaos itself composes symphonies. Maybe the universe plays instruments we have yet to. We call them patterns. The human mind cannot leave dots unconnected. It traces lines even across the void. That instinct built both science and story. Without it, we'd never look up. Even if 3I/Atlas, Borisov, and Oumuamua are unrelated, the meaning we draw from them still matters. Connection, imagined or real, is how consciousness maps infinity. 3I/Atlas makes us wonder if they're linked. Could they come from one source, a distant stellar nursery scattering fragments into the galaxy? Maybe a gravitational chain reaction hurled them one after another, sending siblings on different travelers returning to tell of where it came from, carrying echoes of the first two in its chemistry and its motion. Perhaps they're fragments of one ancient system. Imagine a planet shattered by a dying star, pieces flung outward, frozen, traveling for eons. Over time, those fragments scatter across the spiral arms of the Milky Way, some eventually wandering into our solar system. Oumuamua. Memory resurfacing, a shard of one forgotten world brushing against ours to remind us that creation and destruction are the same dance, only viewed from different steps, or echoes of different. 3 attempts, 3 ages of exploration overlapping in space-time. Perhaps civilizations rise, send messengers, then fade, leaving relics that drift until another world finds them. Our telescopes may have captured not their technology, but their history, silent ambassadors from the galaxy's long memory. It's a thought both lonely and intimate, that others once looked outward, as we do now, wondering if someone might notice. Whatever the truth, each visit shrinks our cosmic loneliness. Whether natural or intentional, icy or engineered, every interstellar visitor reminds us. We are not isolated. We are observed by the unknown. As 3I/Atlas departs, fading back into the silence between stars, it leaves us with the same realization that Oumuamua and Borisov did before. Reflection, evidence that the unknown not only exists, but occasionally comes close enough to remind us of it. The cosmos may not speak, but through these wanderers, it acknowledges our gaze. And in that exchange of awareness, our loneliness dissolves into wonder. 3I/Atlas entered the solar system from the direction of Sagitta, far beyond Pluto's orbit, in the quiet frontier where sunlight is weak and cold dust drifts like fog. A small object approached from the constellation Sagitta, the Arrow. The name feels fitting because that's what it was, an arrow from another world, aimed unknowingly at our star. In the deep background, Sagitta is little more than a pattern of faint points between Aquila and Vulpecula, but to astronomers tracing orbits, it became a gateway. Months, yet carry the weight of millions of years of travel. Speed, around 90 kilometers per second. At that pace, the traveler covers the distance from Hanoi to Paris in less than a second. 90 kilometers per second, fast enough to escape any planet, any orbit, any pursuit. Nothing human-made moves so swiftly except beams of light and bursts of radiation. Such speed hints at it. Of seconds, 3I/Atlas is motion incarnate, a reminder that space, for all its stillness, is built on ceaseless flight. Faster than any man-made craft. Voyager 1, our farthest ambassador, travels at 17 kilometers per second. Parker's solar probe, humanity's swiftest, touches 200 kilometers per second only in brief, fiery arcs near the sun. Yet 3I/Atlas arrived already carrying its own. Inertia, no rockets, no fuel, only the momentum of an ancient ejection. Compared to it, our probes crawl. Its effortless speed is a humbling sight, a natural traveler reminding us how young our machines still are. Perhaps, someday, we'll build crafts that glide as freely through interstellar space, not by burning engines, but by mastering gravity's grace as 3I/Atlas has for ages. It crossed Jupiter's orbit in August 2025. When 3I/Atlas passed Jupiter's domain, the gas giant's gravity tugged subtly, bending its path by fractions of a degree. The encounter lasted days, a cosmic handshake across hundreds of millions of kilometers. Telescopes on Earth and spacecraft in orbit around Mars both caught faint glimpses of it, a tiny point of emerald light against the black. In those frames, we watched an interstellar object share the stage with one of our system's oldest guardians. Gravity introduced them, then let the visitor continue its journey inward. Our innermost planet rarely shares its region of space with visitors. To find 3I/Atlas, there was to watch a guest enter a forbidden sanctuary. The sun dominated every view, even the dark side of the. Our star and the stranger were neighbors, close enough that their energies mingled in a dance of plasma and gravity. Temperatures rose above 400 degrees Celsius on its surface. At those temperatures, lead melts and iron softens. For 3I/Atlas, it was a trial by fire. The outer layers boiled away, releasing jets of carbon dioxide, ammonia, and organic vapors. What had been frozen solid for millions? It was a breath, proof that the traveler still held energy to give. Space probes watched, but kept a safe distance. Parker's solar probe and solar orbiter were in position to observe, but not to. Interstellar visitor. Each measurement added a pixel to the larger portrait, a collaboration between human engineering and cosmic chance. We were witnesses, not participants, watching safely as a miracle unfolded a few million kilometers away. The Solar and Heliospheric Observatory captured frames. SOHO, a sentinel that has watched the sun since 1995, recorded 3I/Atlas as a tiny moving spark near the blinding disk. In its coronagraph images, the jet appeared as a hair-thin ray, flickering and fading. Scientists enhanced the frames, stacked them, and watched motion become story. Astronomers contributed too, a global team. From backyards and balconies, observers joined the mission. They shared coordinates, compared brightness curves, and stitched together images from every hemisphere. The event became a worldwide collaboration of night owls and dreamers, each tracking a fleeting glow against the infinite. In a time when distance often divides us, 3I/Atlas united humanity for a moment in a shared sky. Science grew richer not just through data but through connection, a constellation of curiosity spanning Earth itself. As it swung around the sun, even the most sensitive telescopes lost sight of it. Cameras saw only light. For weeks, we waited blind, listening through data streams for any hint of survival. It was a strange silence, the kind that feels like a pause in a story. Would it disintegrate like so many comets before it? Or would it emerge, scarred but whole? All we could do was wait and trust that light would speak again. No new signal, no confirmation. Then one day, a faint trace appeared in the images, a tiny point moving away from the sun's edge. It had survived. The announcement spread like warmth through the community. Something born around another star had dared to kiss ours and lived to continue the journey. It did. A little dimmed, but alive. Emerging from behind the sun, 3I/Atlas was fainter. Its coma smaller, its jet weaker, yet unmistakably intact. It had shed mass, but not spirit. Like a traveler passing through fire and carrying ashes as memory, it continued onward, glowing softly. Close approaches to massive bodies always change paths, but the post-solar arc of 3I/Atlas showed an unexpected precision. The sun's gravity and the jet's reaction force combined to nudge its angle by fractions of a degree. Tiny on paper, immense in distance, enough to send it on a new heading entirely. From that moment, it was bound not for the inner planets, but for the outer dark. Constellation Draco, the dragon, coiling around the north celestial pole. It's symbolic, the dragon guarding the sky, and now a comet flying through its realm. From there, it will fade beyond reach. Temperatures drop to near absolute zero and cosmic rays become its only company. It will sleep again, unchanged for millions of years, until some other star draws it in. Its visit to us will become a footnote in its endless voyage. No return, no orbit, just a passing hello. There is something tender about encounters without return. They remind us that beauty need not last to matter. 3I/Atlas did not come to stay. It came to be seen. A single wave from the infinite, acknowledged by those who happen to be looking. Each spectral line is a message from its atoms. Light is language. The oldest one the universe speaks. When atoms absorb or release energy, they mark it in color, etching bright and dark bands into the spectrum. Each line tells a story of composition, of temperature, of age. When scientists split the light from 3I/Atlas into its spectral rainbow, they weren't just looking at color, they were reading sentences written in physics. Every wavelength became a whisper. Hydrogen murmuring of its birth, carbon humming of frozen ices, metals shining like punctuation. It was as though the object had written a long letter during its interstellar journey, and only now, as sunlight touched it, could we finally begin to read. Infrared signatures show crystalline ice unlike Earth's. Infrared instruments revealed that its ice wasn't amorphous, like frozen gas in most comets. Instead, it showed crystalline order, a pattern that forms only after repeated cycles of heating and cooling. That means 3I/Atlas had once been warmed by a star, perhaps its home sun, before drifting into cold exile. The structure of those crystals holds memory, the rhythm of expansion and contraction, the trace of ancient warmth now millions of years old. Earth's ice remembers winters. 3I/Atlas remembers stars. Nickel and magnesium bands suggest ancient cores. Among the spectral peaks were faint bands belonging to nickel and magnesium, metals forged in the hearts of stars and in the crusts of planets. Their presence hinted that 3I/Atlas might once have been part of a larger world, a planetary fragment, not just a comet. Perhaps an impact or gravitational slingshot tore it free, sending it adrift. If so, the metals are fossils of a long-dead planet, now crossing the galaxy in silence. The object is not just ice and dust, it is archaeology in motion, carrying relics of stellar history. Through endless night, density models hint at porous interior. By comparing its light curve to its estimated mass, scientists inferred that 3I/Atlas is far less dense than rock, maybe half the density of water. That means it's mostly empty space inside, a fragile honeycomb of voids and frozen gases. Such porosity explains its resilience, the ability to absorb impacts and survive close passes near the sun. It's not solid like a stone, but flexible like a sponge of space dust. Within those tiny hollows, gases sleep, pressure builds, and occasionally, light escapes, the way of breath. A comet of contradictions, a sculpture carved by absence. Its essence is not mass, but interaction, the brief shimmer that happens when sunlight and emptiness meet halfway. Its light curve tells From that pulse, scientists deduced both its rotation speed and the rate of sublimation. Every spike, every dip, corresponds to a moment of awakening, a patch of ice turning to gas, releasing light as it goes. The light curve is a diary, one written in photons instead of ink. In it, we see not just motion, but emotion, a rhythm between stillness and release. Data noise hides unexpected pulses. Deep in the raw recordings, the parts most researchers discard as noise. A few analysts noticed faint, repeating spikes. Tiny oscillations in brightness, subtle yet consistent, flickering at regular intervals. At first they were dismissed as processing errors, sensor drift, or cosmic rays. But they persisted across instruments and observatories. The pulses didn't match. Explanation: the pulses came from rotating vents, releasing gas like a sprinkler. Each turn exposed a jet to sunlight, causing a brief flare before shadow returned. It fit the models, elegant, natural, mechanical, a comet breathing light in perfect rhythm with its spin. And yet, the precision was haunting. Intervals so steady they could have been measured by a clock. Nature often outdoes human design and symmetry. Still, the thought lingered. What if there was more beneath the rotation? Others, as signal patterns. A smaller, more daring group wondered aloud. Could the regularity be communication? Not in words, but in timing. Bursts of brightness as data, binary encoded in light. No evidence supported it. Every scientist who proposed it did so with a nervous laugh. But even to consider it showed how far curiosity stretches when faced with silence. Perhaps no one expected the object to speak. But who could resist listening, just in case? Machine learning was used to clean the data. Algorithms trained to remove noise from astrophysical signals were turned loose on 3I/Atlas. They sifted terabytes of spectral and brightness data, filtering solar interference and cosmic background radiation. In the cleaned results, subtle harmonics emerged. Not words, not music, but structured variation. The machines, built to find order in chaos. No artificial signal was found, yet. SETI researchers ran the cleaned light curves through detection models designed for extraterrestrial signals. No modulation consistent with technology appeared. Spin, but not with its orbit. Temperature, brightness, jet activity, all in sync. It could be coincidence or resonance, or simply human bias seeing music in static. But the numbers pulsed like a heartbeat, and data analysts, despite themselves, began calling it the rhythm. Science lives on precision, yet sometimes it flirts with poetry. The temperature profile fluctuated rhythmically. Before the surface caught up, it was almost like respiration. Inhale, exhale, thermal equilibrium achieved through motion. Whether chemical or structural, the rhythm gave the object personality. It wasn't a dead rock. It was dynamic, reactive, alive in its physics if not its spirit. The period matched its rotation cycle. When researchers plotted temperature, brightness, and jet intensity together, all three aligned with the same rhythm. Every 9 hours, as the body turned, it flashed, warmed, and sighed in vapor. Rotation became heartbeat. The numbers told a story without words. The cadence of motion meeting heat, the balance between light and darkness. In its quiet mathematics, 3I/Atlas revealed what life and stars share, the inevitability of cycles, or a transmission interval. To the most speculative minds, 9 hours sounded suspiciously like a timer. What if the rotations were not random, but purposeful? What if the vent wasn't a vent, but a beacon firing at predictable intervals? No evidence supported it, yet imagination refuses silence. Science said spin. Curiosity whispered signal. Between the two lies the territory of wonder, where data and dreams overlap. Data does not speak. We translate its silence. Numbers themselves have no voice. Interpretation is our gift and our flaw. We project emotion onto graphs, intent onto curves. Still, within that act of translation lies connection, the realization that the universe only becomes meaningful when seen through consciousness. 3I/Atlas may not speak, but in trying to understand it, we hear echoes of ourselves. Its silence teaches as much as any message could. 3I/Atlas keeps its secrets within light. Light leaves, travels, bends, and fades, carrying truth like pollen across the never through sound. It offers no confession, only evidence, and asks us to read carefully between the rays. And our instruments keep listening, even after it faded beyond optical reach. Observatories stayed tuned. Infrared, radio, ultraviolet, all searching for echoes. The data trickled in, faint but steady, like embers cooling after a great fire. Somewhere in those faint readings might hide a new clue, a new anomaly. The search never truly ends. It only grows quieter. Listening becomes both science and meditation, a vigil kept in numbers. One day, we may decode a pattern that answers back. It might not come from this object, or the next, or even within our lifetimes. But someday, in the noise of starlight, we may find a pattern that isn't natural, a rhythm that repeats across systems, across ages. That day will change everything. Not because the universe will have spoken, but because we will finally have learned to hear it. Until then, every anomaly is but in patience. Each digit, each pixel, each photon is part of a cosmic lullaby, a rhythm that soothes those who study it, inviting sleep, reflection, and awe. 3I/Atlas sings without intention. And we, the listeners, fall quietly into its spell. In the end, maybe the universe was never trying to send a message at all. Maybe it was only trying to remind us how to listen. Every discovery, the first movement in the symphony of understanding. It is the moment when reality exceeds imagination and forces us to expand both. Every great leap, from Galileo's moons to Einstein's relativity, began not with certainty, but with awe. 3I/Atlas continues that lineage. It didn't arrive to solve a mystery, it arrived to be one. And in doing so, It reminded us that wonder isn't the opposite of knowledge, it's the door that opens to it. 3i/Atlas reminded us how small and curious we still are. For all our technology and telescopes, we remain children staring at the sky. Each time we point our instruments outward, we rediscover humility. This visitor, a 10-kilometer fragment from nowhere, made our vast world feel tiny. It reminded us that the unknown still surrounds us, not as threat, but as invitation. To be small in such a universe is not defeat, it's participation. Curiosity, not conquest, is what binds us to the stars. Its visit is a whisper from the deep universe. So quiet, it could be mistaken for coincidence. Yet every whisper carries intention, even if unspoken. From interstellar space came a murmur, a body of ice and dust passing close enough for us to notice, then fading again. The timing, the geometry, the fleetingness, all felt like a message written in patience. Not a voice that says, "Look at me," but one that says, "Remember how wide existence truly is." Whispers like these are what keep the silence of the cosmos from feeling empty. We spend our lives under one star, yet others call from afar. For all of history, humanity has known only the 3i/Atlas may carry the chemistry of a sunrise we will never see, yet somehow we can still witness its reflection through data and color. To study it is to hold another dawn in our hands. What if every system sends out its wanderers, like cosmic greetings? Perhaps these travelers are not accidents, but inevitabilities, the universe's way of letting its parts stay in touch. Of probability. Through them, stars exchange dust and data, trading the raw material of creation. It's comforting to imagine that, across light years, the galaxy is constantly whispering hello. Found. Perhaps it isn't machinery, but metaphor. Proof that communication doesn't always need language. Even if no one sent it, the effect is the same. It reached intelligent eyes. It reminded us that connection can occur without contact, that meaning can arise even from chance. In noticing it, we completed the circuit, message and receiver united by curiosity, or a fossil of a world long gone. Maybe 3i/Atlas isn't a postcard, but a relic, a piece of a planet shattered by time, carrying within it minerals, ice, and memory. Each grain of dust inside could be older than our sun, a geological ghost of another age. In studying it, we hold dialogue with the dead, not of our species, but of cosmic ancestry. Its silence feels sacred, like the calm of ruins untouched by life for millennia. Through it, we see how even extinction can still travel, still speak, still matter. It shows that matter moves, memory moves, existence moves. Nothing stays where it begins. Stars drift. Memory in motion. Existence refusing stillness. It tells us that permanence is not the goal of the universe. Continuity is. Nothing in the universe truly stays still, even in what we call rest. Particles vibrate, gravity ripples, time flows. Stillness is an illusion created by limited perspective. From the microscopic to the galactic, everything dances. 3i/Atlas, drifting through our clocks to measure. Even the sun wobbles slightly, pulled by unseen forces. Our star seems immovable, yet it sways, gently, rhythmically, tugged by the gravity of its planets. Jupiter, especially, makes the sun orbit a tiny point outside itself. That means even our central star is never truly at rest. It moves in deference to its companions. The sun, the source of all stability, is itself in motion. So when we speak of wanderers like 3i/Atlas, we should remember, the universe has no fixed center. Everything is both traveler and destination. So perhaps, in a grander sense, the universe is alive. Not alive in biology, but in motion, in feedback, in awareness. Energy flows, matter transforms, stars are born and die. like cells in a cosmic organism. Information pulses, is not separate from life. It's a neuron firing, part of the great mind of existence. Its comets are neurons, firing across interstellar distances. Each comet, asteroid, or ray of light becomes a spark, a signal traveling through the galactic network. Some sparks fade, others trigger reactions. 3I/Atlas, passing through our system, could be one such firing, brief but significant. Every observation we make feeds back into awareness itself, because consciousness is the universe learning about its own form. 3I/Atlas is one node in that endless network, a transmission from nowhere that activates recognition in us. For a moment, star and species share a wavelength, not of sound, but of understanding. When we observe, we become part of the thought. To look is to, not physically, but symbolically. In that moment, we were no longer just spectators. We were neurons responding, completing the circuit of cosmic thought. The act of looking ties us to the infinite. Every time a human eye or lens gazes upward, a connection forms between finiteness and forever. Looking at 3I/Atlas was not merely seeing, it was communion. It reminded us that infinity is not something outside of us. It's something we're embedded in, constantly exchanging awareness with. To look into the void and find meaning is one of humanity's oldest gestures. And each time we do it, the void looks back, reshaping us in ways unseen but deeply felt. Maybe the real energy being exchanged isn't sunlight, but awareness. Physics measures joules and watts, but something subtler travels too. Every observation transfers not just photons, but curiosity, the conscious counterpart to light. The sun illuminated 3I/Atlas. 3I/Atlas illuminated us. Between them flowed more than energy, there was recognition. Perhaps awareness, like radiation, moves in waves, invisible, unmeasured, but profoundly real. And when it meets reflection, it expands. 3I/Atlas didn't just draw energy from the sun, it drew wonder from us. While the star fed it warmth, humanity fed it meaning. We named it, tracked it, mythologized it. The object's journey became our mirror, proof that even in an age of science, we still hunger for astonishment. Our fascination was its true legacy. For as it passed the sun, it also ignited imagination, spreading like light through every telescope, every conversation, every sleepless night staring upward. And that wonder is what keeps civilization awake at night. Not fear, not ambition, but wonder. It is the quiet fuel behind invention, art, and exploration. It drives us to ask questions for which we may never have answers. Every observatory, every classroom, every story told under a starlit sky is powered by that same current. From that seed came everything: atoms, planets, consciousness, curiosity. 3I/Atlas is just one expression of it, and so are we. The object will fade, its jet will die, its light will vanish. But the wonder it sparked will remain, flowing from one generation of minds to the next, the one form of energy that never truly dissipates. Now 3I/Atlas is leaving. The moment of encounter is our sun, carrying the faint glow of its recent passage, a trace of brightness fading into the infinite. No engines, no signal, no goodbye, only motion. The same momentum that brought it here now carries it away, a story ending where it began, in silence. Slowly fading into the outer dark beyond Neptune's path. Past Neptune, the sun becomes a pale disk, not the ruler of the sky. Its light is weaker, its jet now silent. Once, it glowed with vitality, green gases shimmering, sunlight sparking through its vapor. Now the vents have sealed, the gas is frozen again. No more breath, no more beam. Only inert reflection, faint and fading. To telescopes, It's no longer a spectacle, but a dim star-like speck slipping away. But that dimness is not death, it's rest. After all, every journey deserves silence at its end. Dust trails shimmer behind like the memory of a dream. In its wake, a thin trail of dust lingers, a faint filament stretching across millions of kilometers. It glows briefly in reflected sunlight before dispersing into nothingness. Those grains will wander separately now, each a seed of light, each carrying memory of the traveler that. Another star. At its current speed, 3I/Atlas may wander for 1,000,000 years before another star's gravity bends its course. 1,000,000 years, long enough for continents to shift, for civilizations to. An envoy of persistence. To drift is its destiny, to endure is its art. Perhaps one day, someone else will see it, and wonder too. Another civilization, orbiting another star, might one day detect it, just as we did. In that moment, we will have unknowingly shared a thought across the galaxy. Wonder. No message will have been sent, and yet a connection will exist, written not in language, but in curiosity. Its frozen body will carry traces of our sun's touch. The heat of our star left a mark, microscopic cracks, altered isotopes, rearranged ice crystals. These are fingerprints of the sun, etched permanently into the comet's skin. When future beings find it, they will see traces of warmth from a distant yellow star and know that, once, it passed through light. Our star's energy. The crystalline structure. When scientists map that lattice, they can tell where the object has been, how close it came, how hot it became, how quickly it cooled. In that sense, 3I/Atlas is a diary. Meaning, stars illuminate, minds interpret. Between those two acts lies everything that makes existence beautiful. The sun's photons gave 3I/Atlas form and visibility. Our curiosity gave it purpose. And poetry. Without our attention, it would be just another rock. But the moment we noticed it, it became a story, proof that meaning is not found in the universe, but created within it. In that exchange, both star and visitor changed forever. The sun lost a few atoms of energy to light. The comet gained scars of heat and motion. And we, in watching, were transformed too. The interaction altered not just matter, but awareness. We became participants in a cosmic dialogue, star, traveler, and observer forming a triangle of transformation. That is the quiet power of observation. It changes everything, even the silent. That is the beauty of cosmic meetings, brief, yet eternal. Encounters in space rarely last, but their echoes stretch forever. Gravity, light, and time weave relationships that outlive the participants. 3I/Atlas may be gone, but the equations describing its path will endure in human archives long after we fade. Its image will linger in the memories of those who watched it, and in the atoms that once touched sunlight together. Eternity doesn't require permanence, only remembrance. Maybe 3I/Atlas is not a machine or a comet, but a unfolding before our eyes. We often speak of the cosmos as ancient, complete, mapped. Yet discoveries like 3I/Atlas prove otherwise. The universe continues to surprise us, still growing. Is more? That new mysteries can appear even in familiar skies. We think of our sky as known, constellations mapped, planets named. But even now, something new can streak through that familiarity and make it strange again. That is the true gift of such encounters. They return mystery to the mundane. The sky above hasn't changed, we have. It is still infinite, still wild, still whispering. Written across the firmament, we project our emotions onto that movement. Longing, curiosity, hope. 3I/Atlas provided another chapter in that cosmic storybook, a tale of travel and transformation. Told not in words, but in trajectory. We may never know its purpose, but we know its direction, onward. Every comet, every star, every visitor, a sentence in the language of space. The universe speaks through patterns, repetition, rhythm. Each orbit, each rotation, each flash of light is punctuation in a language older than atoms. To read it, we use telescopes instead of tongues, equations instead of grammar. 3I/Atlas was one sentence, brief, luminous, perfectly phrased. Its meaning is still being translated, but its presence already enriches the cosmic poem. Did it change course intentionally, or by physics alone? The answers may never reach us. Yet that uncertainty is what keeps our species looking upward. In asking, we stay awake within creation. Did it come to feed, to learn, or to simply pass by? If we anthropomorphize the cosmos, it becomes a mirror. Was 3I/Atlas a student, a thief, a messenger, or just a wanderer seeking warmth? Maybe those categories don't apply. Maybe existence doesn't need motive. Sometimes, things just move because motion is the only truth the universe recognizes. Still, it's beautiful to imagine. Purpose. Even if that purpose is only to make us imagine. We may never know. But that's the nature of wonder, to remain. Answers in stories. Wonder keeps them alive. Science advances by closing questions, but imagination thrives by leaving them open. 3I/Atlas offered both. Data to analyze, and mystery to dream upon. Its uncertainty is its legacy, a reminder that not everything precious must be solved. Some things are meant to remain slightly beyond comprehension, so that curiosity never sleeps. And as you close your eyes tonight, imagine it still gliding, silently, between the stars. Out there, beyond our system's faintest edge, it moves through eternal night. No engines hum, no light burns, only momentum and memory. It drifts past clouds of dust, past frozen worlds, past forgotten signals. Perhaps, in the stillness, it hums softly, not in sound, but in presence. And as you fall asleep beneath your own familiar sky, know that it continues, a small. But in us, every time we wonder, we reignite it. Every time we look up, we pull a little piece of its journey back into our imagination. It came from nowhere, and returned to nowhere. But between those two nothings, it touched the sun and us. That brief crossing, that single heartbeat in cosmic time, is enough to remind us how alive curiosity really is. So tonight, as your thoughts drift,